Hi students. So we have already seen that reflection of a plane wavefront or the proof for the laws of reflection. Now we are going to see the proof for the laws of refraction or the refraction of a plane wavefront on a refracting surface. Here the refracting surface we may consider as the water surface or any transparent glass medium, right? Now here refraction of a plane wavefront on a refracting surface, right? Now, here xy be the surface of separation which separates two medium. This is rarer medium and this is denser medium. Here the rarer medium has the velocity of light c1, the refractive index mu1. Here the denser medium has the velocity of light c2 and the refractive index mu2. Now, as we have said already in our reflection of a plane wavefront video, that is, two light rays from an infinite source are going to incident on this refracting surface. That is, this is a surface which separates two medium. It may be the water surface or any transparent glass medium. So these are the two rays which are incident on this refracting surface, that is PA and QBC. So this AB is called as the incident plane wavefront. Since the sources are infinite distance, the wavefront obtained here is the plane wavefront. So this plane wavefront is incident at the point A. These two rays are perpendicular to the plane wavefront. Also, this plane wavefront AB is perpendicular to the plane of the board. Now, I am going to draw a normal at the point A. So this is NAN1. NAN1 be the normal. So this is angle of incidence like that. Now I say, as usual, according to Heisenberg's principle, this is the wavefront, plane wavefront. Each point on this plane wavefront act as a source of secondary wavelets. Now, by the time the wavelet from the point B reaches C, a wavelet from A would have traveled a distance. That distance we are going to measure. Here, the distance BC is nothing but the velocity of light into time taken. Here, the AD is nothing but the velocity of light c2 into time taken. Right? So, from this, T is equal to BC by C1. So, when I substitute the value of T in this AD, I get AD is equal to C2 into BC by C1. So, now I say by the time the wavelet from B reaches C, a wavelet from A would have traveled a distance is equal to C2 into BC by C1. So the distance from the point A, right? The distance traveled by the wavelet from the point A is equal to C2 BC by C1. So keeping the distance AD or keeping the distance C2 into BC by C1 as radius and A as center. So this is the refracted ray. So draw an arc. From the point C, draw a tangent which touches this arc. Mark this point as D. Here, this is the angle of refraction. And CD CD is called as the refracted plane wavefront. AD is called as the refracted ray. So this is angle of refraction, right? So AB is the incident plane wavefront, CD is the refracted plane wavefront, right? Now, so according to the first law of refraction, the incident wavefront, the refracted wavefront, here the incident plane wavefront, the refracted plane wavefront and the normal lie on the same plane. So according to the second law of refraction, we have to use Snell's law. Now keep this thing as it is. Okay. The first thing is, so here from this triangle, angle PAN plus NAB, so they are 90 degree. So angle PAN plus angle NAB is equal to 90 degree. Also, angle of incidence is equal to angle tan, which is also equal to 90 degree minus NAB, which is also equal to, so here BAC, back, pan, NAB, back, right? So this is the angle of incidence. And here, when I take this N1A, right, this thing, so N1AD and DAC, they are also 90 degree. So N1AD plus DAC is equal to 90 degree, or the angle of refraction is equal to N1AD, that is this angle, right, which is also equal to 90 degree minus angle DAC, which is also equal to ACD. So NAD, DAC, ACD. So they are all the angle of refraction. Now using Snell's law, we know that sin I by sin R is equal to some mu. Now this is nothing but, sin I is nothing but, so BC by AC. Sin R is nothing but AD by AC. Because, so this is angle of incidence opposite, hypotenuse, adjacent. So opposite by hypotenuse is this. And here, this is the opposite side, this is the hypotenuse, this is the adjacent side. So opposite by hypotenuse, that is AD by AC, is this. Now, AC get cancelled. So sin I by sin R is equal to BC by AD is nothing but, we have seen that the distance AD as C2T, that is C2 into BC by C1. So C2 into BC by C1. So BC get cancelled. So I get C1 by C2. Here this mu is greater than 1, that is C1 by C2 is also greater than 1. It shows that the velocity of light is always greater. The velocity of light in a rarer medium is always greater than the velocity of light in denser medium. So C1 is greater than C2. So it is proved here from the second law of refraction that the velocity of light in rarer medium is greater than the velocity of light in denser medium. So C1 by C2 is greater than 1. So I think you must have understood. And also remember that, see, whenever the light rays are reflected from the surface, from any surface, right, or refracted through any surface, the frequency of the light waves will not change at all. It will remain the same. But whenever the light rays are refracted in a medium, so refracted from a denser medium to a rarer medium, right? So now the wavelength of light will alone change. So whenever the light rays are refracted from rarer to denser or denser to rarer, anything else. So whenever the light rays are refracted, only the wavelength changes, not the frequency. Because you might have seen when light rays enter into water, the intensity of light waves would have been reduced somewhat. The brightness would have been reduced. So the wavelength of the light changes. Now, so remember this C1 by C2 is equal to, so nu into lambda 1, nu into lambda 2. If I put here as Ca as m, so velocity of light in the rarer medium, that is air or vacuum, velocity of light in denser medium or any medium, right? So I can write this as lambda a, lambda m. Since there is no change in frequency in both the cases, whether reflection or refraction, nu remains the same. So nu will be same. It is getting cancelled. So the velocity of light in rarer medium by velocity of light in denser medium is equal to lambda a by lambda m, which is nothing but the refractive index of any medium. Right? So this is the proof for the laws of refraction. I think you would have understood. Thank you.